Hi, I'm Dr. George Thompson. I have been President and CEO of the family-owned Chemical Compliance Systems for the past 32 years. I'm also a toxicologist and functioned in that role for nearly 50 years. Toxicology is the science of poisons and measures chemical and product hazards and determines exposure conditions that cause risks to people and the environment. For example, formaldehyde is a very hazardous chemical, but is present in bananas that we eat. Arsenic is in rat poisons, but in the potatoes we eat. Hazardous materials can be used safely depending upon their usage and concentrations. This video will help you understand a little about how Chemical Compliance Systems has simplified complex procedures for scoring chemical hazards and product risks and teaching them to chemists so they become green chemists. Chemistry is the science of chemicals. Green chemistry applies to toxicology principles that reduce or eliminate hazard substances in chemical products. If we can teach toxicology concepts to chemists, as proposed in this project, we can successfully develop green chemists that can create safer chemicals products and reduce environmental pollution. Unfortunately, colleges and universities do not have funds to license effective teaching tools like our Green Chemistry student tutorial module. Sufficient donations from you over the next 30 days will cover our licensing fees and enable Chemical Compliance Systems to provide Green Chemistry student tutorial module free of charge to 20 colleges or university chemistry departments. This system has as its backbone our relational chemical and product database. We estimate we've been compiling this since 1985 and estimate that we have over 80 million data elements now. It is the largest database of its type in the world. We have over 280,000 chemicals in this database and more than 29,000 chemicals with detailed 44 ecological health and safety endpoints that we have accumulated from over 1,000 publicly available sources. This system works by defining a green chemical product, process, or waste stream with numerous layers in the hierarchical scoring system. We can start by defining what is a green chemical or product. It includes ecological health and safety information. The ecological must cover water, air, and soil. Health must cover acute or short-term health risks and chronic or long-term health risks. And safety can cover things including fire scores or flammability, special categories, and radioactivity. The 44 endpoints that we use in this system were derived from a national standard promulgated by a committee of over 100 people from academia, from government agencies, from industry, and from non-governmental organizations. This green report card from our Green Chemistry student tutorial module shows how the results can be printed out and summarized. You may not be able to read all of the fine print, but you can see all of the red color here. Anything in red is of concern. The green grade is a very low score of 46 out of 100. The ecological score, health score, and safety categories are all red. The subcategories are almost all red, and many of the 44 endpoints are red. So it's clear that this chemical formaldehyde is a hazardous chemical. But if we dilute it significantly, these red scores can all turn to black, and the score can be in the upper range of 97 to 99 out of 100, which means it's not hazardous any longer with sufficient dilution. Our Green Chemistry student tutorial module in the center of this chart is actually one of 10 different optional modules that we use to analyze chemicals in our enhanced green suite. 7 of the modules utilize the 44 endpoints, including the student tutorial module. This student tutorial module is actually a combination of the chemical module and the product module, but designed in such a way that it can be used to teach chemists how to become green chemists. That software system in the student tutorial module is complemented by our textbook and actually a workbook as well that covers chemical hazards and product risk assessments principles. This textbook also includes assignments that students must fulfill, questions that they must answer utilizing the student tutorial module online. And in this way they can take their knowledge of chemistry, merge it with the information about toxicology, chemical hazards, and product risks, and become green chemists. So the purpose of this strategy is to ask you to help us help these students, in turn help you and the public and our planet. If we can help the chemists become green chemists, then those green chemists can make safer chemical products and manufacturing processes. The net result is we can have healthier consumers, safer workers, and less pollution, and at the same time decrease the risk of global warming. As a toxicologist in my waning years of my career, I sincerely hope you will be generous in helping us help the students, help consumers, and our planet. And please tell your friends about this project. I thank you for watching this video. I pledge to sustain my efforts to see green chemistry become the standard for the future, as long as the good Lord sustains my health and inspires my thoughts. Thank you.